Now what we're going to be looking at today is kind of looking at actual numbers and data that represent either exponential or logger or kind of exponential functions. Now, if we look at an exponential function, the numbers for it, so I'm just going to pick, say, 5 to the x, and table. Those numbers got big. Well, at 0, we know it's going to be 1. And at 1, it becomes 5. 2, it becomes 25. 3, it's 125. 4 is 625. Well, what's happening from one number to the next for our y values, our output values? It is increasing. By how much? All right, from here to here, we have times 5. From here to here, it's a multiple of every single time we have this factor of 5, we're multiplying it by, yes? Okay. Well, maybe it's just this here. Let's look at another one. Let's see here. Y equals, let's change it to 7. So we have 1, 7, 49, 343, 2,401. But we're still having that multiple of 7. So if we're talking about exponential functions, really the output values should be increasing by multiples of 7, or we should have this rate of 7, this multiplication of 7, as it increases. Now this doesn't work for any function like this, because if we had it the other way around, let's just say x squared, our quadratic. Well, if we notice the numbers for the quadratic, they don't increase in that same way. Because for the quadratic, we go 0, 1, 4, 9, 16, 25, 36, 49. They're increasing, but they're not increasing at a common rate, are they? Well, the difference here is 1, 3, 5, 7, 9, 11, because the difference between each number is different, yes? Wait a minute. What's the difference between 1 and 3? 3 and 5. 5 and 7. 7 and 9. But it works out for any quadratic, anything where we have x squared, the difference of the difference is always going to be the same. And this is one way, especially if you're looking at sets of numbers, to really be able to tell the difference. Especially to know if the series of numbers is a quadratic or not. Because if the difference of the difference is the same, then it is a quadratic of some degree. We can't tell exactly what it is, but we know that it should have a quadratic or be a quadratic of some kind. And that's really what we're going to be looking at to start. We're going to be classifying data, at least to start with. You have to analyze finite differences of data with equally spaced inputs to determine what kind of polynomial function can be used to model the data. For exponential data with equally spaced inputs, the outputs are multiplied by a constant factor. So consecutive outputs form a constant ratio. So if we look at any set of numbers and the outputs have a common ratio between one and the next, then it is expected to be exponential. So if we look at this here, is there a common ratio between all of these numbers here? And it would be? Because we can see it here, because here's a times 2, times 2, times 2, times 2, times 2, and it does work out here. So this here would be exponential. It's an exponential function because we do have this constant increase by a ratio of 2. Now another way we can see if we have a common ratio is dividing new over old. So we can say 1 over 0.5. And what is 1 divided by 0.5? And we can do the next one. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8, 2. And 36 divided by is 2. There's going to be this common ratio between any two consecutive outputs. So it'd be exponential. And how about this one here? What can we say about this one here? So 0 over 2 is 2 over 0 is undefined. We can't divide by 0. So that doesn't work, because if we have a common ratio, it has to be the same across every single number. And these outputs are increasing by 2, so there is a uniformity in that, so we can still do this if it had a common ratio. Bless you. What is the difference between 2 and 0? Negative 2, because we're going down. 0 and 2 is 2 and 8. 8 and 18. 18 and 32. 32 and 50. Okay. Let's do it one more time. Negative 2 and 2 is? 2 and 6. 6 and 10. 10 and 14. Well, this is an exponential, sorry. This would be considered it's a quadratic. Because if the difference of the difference is the same, is the exact same, then it's considered to be a quadratic function. Now, we'd have to do some more calculations to see exactly what kind of quadratic we would have. But this is definitely a quadratic function. Mm-hmm. Yep. Because here we want it to be a constant change across all of them for us to be able to look at the data. Because if it's increasing at different amounts, it's going to be harder to see what is actually happening. Because x is the input values, but the inputs are going along a linear, a constant rate. And we want them to be the same. But we're really focused on the output values to see how is the function operating, how is it working. So here we do have a constant, negative 2, negative 1, 0, 1, 2, 3. So that's fine. But we want to see about the y values. So we can do new over old. 81 over 243. So as a fraction, okay, let's do the next one. 27 over 81. 9 over 27. 3 over 9. And lastly, we have what? So does this have a common ratio. Mm-hmm. And it is? So this here would be considered exponential. It's an exponential function. Any questions? So exponentials do have an inverse, and they are logarithms. Because exponentials and logarithms are inverses of each other. They undo each other. Because when we take, because our inverse functions, when we took f of x and f inverse of x, it got us back to x. One undoes the other. That's what exponentials and logarithms do. One undoes the other. Is to undo natural logs, yes. Any questions? So we're good with this here? Let's look at this one here. This here should really be a giveaway that this is most likely not going to be exponential, because it is decreasing and then increasing. And when we looked at exponentials graphs, they did not have a curve well, they had a curve, but they would either curve up or curve down. They wouldn't curve down and then up. And if we look at this here, well, new over old, 5 over 13 is 5/13, so that's as simplified as it gets. The next one would be 13 over 5. Are these the same? No. So this does not have a common ratio. It doesn't have a common rate from one number to the next, which means that this is not exponential. So we still need to check and make sure. The difference between 13 and 5 is? 5 and 13 is? 13 and 37 is? 37 and 77? 77 and 133.
Because when I did it, I thought you were doing
So new minus old.
5 and then
So 5.
13 and 13 on 37. I got negative for all of them. And it
So like with our ratio, we did new over old. So we can do the same thing with this here, new minus old. So the first one would be 5 minus 13, which would give us negative 8. Then 13 minus 5 is, because we always want to do new minus old to get here. So difference to get to 8 and 8. New minus old is 24 minus 8 is? Any questions on any of this here? So let's look at number 10, or number 1. Because we have 0, 10, 20, 30. So the x's are increasing at a steady rate. The amount of change is the same. So we can look at the y's. So we see if there is a common ratio. So we can check 12 over 15 to see if that's the same as 12 over 9 is the same as 9 over 6. Nope. Because, sorry, 12 over 15, and then it would be 9 over 12, and then 6 over 9, I had them flipped for a second. So 12 over 15 would be? So is there a common ratio between these here? No. So let's see if there's a common difference. This would be? Well, there's already a common difference, yes? Well, if the difference of the difference is the same, then it's quadratic, yes? So it wouldn't be exponential, so quadratic, what's below quadratic? Mm-hmm. It'd be linear. Yep, because we have, for polynomials, we have constants, which is just a number. Degree 1 is linear, degree 2 is quadratic, degree 3 is cubic, degree 4 is quartic, going up. So kind of along that reasoning, so if the difference, the main difference is the same, then it's linear. If the difference of the difference is the same, then it's quadratic. So following that reasoning, what would the difference of the difference of the difference? Cubic. Yes. If they're all the same y, then it would be a different type of function. Possibly, but not on this. We wouldn't go to that level. Because most likely it would be a alternating function. Could be a possibility, or it could be that we're dealing with multiple functions working together. So let's look at this one here. 27, 9, 3, 1. So when you say 9 over 27, 3 over 9, and 1 over 3. Well, 1 over 3 is as simplified as it gets. 9 over 27 would reduce to. So this is spell it one more time. I think I'm adding an S. Expontial. Yep. I always want to add an S into it. Questions on this here? You know that 2 points determine a line. Similarly, 2 points determine an exponential curve. We can use 2 points to determine what an exponential curve is. Now, an exponential function is going to come in the form of y equals a times b to the x. And we're going to use this equation and these 2 points to find out what the function is itself. So when we look at this here, write the equation, write an exponential function, y equals a times b to the x, whose graph passes through these 2 points. So we're using this here, y is equal to a times b to the x. Our first point that we're given is 1, 6. So the x value is 1 and the y value is 6. So I can plug that in here and get 6 is equal to a times b to the first, because x is 1. When x is 3, y is 54, so we'd have 54 is equal to a times b to the third. And what we're going to do is we're going to use these 2 equations together to solve for the values of a and b. Now all the ones that we're going to look at this time around, a and b, or the powers of b for one of them will be 1. We're not going to deal with a case where we have b squared and b to the 5th, where we do have different values or one of them is not 1. So what we're going to do first, and really to solve this, is we want to get a in one of the equations by itself. Because if I can define a, I can plug it into the other equation to solve. So if I look at this here, 6 is equal to a times b to the first. If I want to get the value of a by itself, we can divide both sides by b, because these will cancel, telling me that a is equal to 6 divided by b. Any questions on this so far? Now we can bring it over here and plug it in. Because this here will give us the value of b, and once we find the value of b, then we can solve for the value of a. So if I multiply these here, we'd get 54 is equal to 6b to the third divided by b. Whenever I have a number or two variables in the numerator and denominator that have the same base, we can subtract the exponents. So b to the third divided by b, we can do 3 minus 1, which is b squared. And since the number on top is bigger, the exponent on top is bigger, the number stays in the numerator. The variable stays in the numerator. Now what can we do next to solve for the value of b? Divide both sides by 6, which tells me b squared is equal to we can square root both sides. Tells me b is equal to 3. Now normally we would say plus or minus, but because we know the properties of exponentials, b has to be a positive value. And when we first started talking about this chapter, we saw what happens if b is negative. We get this alternating function because the values went positive, negative, as it increased. So b has to be positive. Any questions on how we found the value of b? Now we need to find the value of a. Well, a is equal to what? 6 divided by, so a is equal to 6 divided by 3. So a is equal to, so we have a and b, yes? And our function, our exponential function, is y is equal to a times b to the x. So for us here, y is equal to, well, a is, b is, so the function is y is equal to 2 times 3 to the x. And that's our answer. Any questions on this here? Let's look at the next one. Yes. Write an exponential function y equals a times b to the x whose graph passes through 110 and 340. And the graph, or the answer would be times 2 to the x, yes. But let's go on and actually solve this through and see how this works. Is we're going to plug each set of numbers in. So one of them, y is equal to 10, is equal to a times b to the first, or y 10 is equal to a times b. Because we plugged in 110 into this function. If we plug the other one in, 40 is equal to a times b to the third. Now again, just like the ones we just did, we want to solve one of these for a because it's going to make it a little bit easier to solve. Since I know that one of our equations has b to the first, that's the one I'm going to use to solve it for a. So we'd get a is equal to 10 divided by b. Any questions on this here so far? So when we plug this back in, we get 40 is equal to 10 divided by b times b to the third. Now looking at this here, we know that one of these b's will cancel out with one of these here. So we really have 10 times b squared. Because we could rewrite it out like we did on the one before, have 10b cubed over b, and we know that one of them would simplify, giving us 10b squared. And then what would we do next? Divide by 10, which tells us b squared is equal to square root both sides. So a is equal to, as we saw already, y is equal to 5 times 2 to the x. Any questions on any of this here? We're going to look at two more of these here. Let's look at this one here. So this one here, I kind of go back on what I said, because we do have an x that's going to be different than 1, but it's not going to be that different than what we did. It's going to be the same type way to solve it. So when I plug this in, we'd have 12 is equal to a times b to the second. We'd also have that 24 is equal to a times b to the third. So we want to solve one of these for the value of a, and I normally want to try to use the one where b has the smaller b value. So for this here, we would divide both sides by b squared, which will tell us that a is equal to 12 divided by b squared. Four is equal to 12 divided by b squared times b to the third. So b to the third and b squared, so the b squared will simplify out how many? 2 of the b to the thirds, which would just leave us with 1. Divide both sides by 12, and we find out the value of b is b is 2. Plug it back in to find the value of a, so a is equal to 12 over 2 squared. What 2 squared is? So the value of a is 3. The value of a would be 3. Any questions on how we found the values of a and b? So at this point here, we would plug it back in. y is equal to a times b to the x. And we would get this equation here. Any questions on any of these here thus far? Yes. Let's look at one more here. We'll look at this one here, and then we'll continue this tomorrow. So we're going to find the exponential function who goes to the point 1, 2, and 3, 32. So if we set this up, it'd be 2 is equal to a times b to the first. Then we would also have 32 is equal to a times b to the third. Then what do we do next? Right, I'm going to divide this one here by b because we want to get a by itself. A is equal to 2 divided by b. And then we take that and plug it in to solve for the rest. So what can we do next? Simplify a little bit. Is b cubed divided by b would become b squared. And then what would we do next? Divide both sides by 2, which will tell me that b squared is equal to and then square root both sides. So we found the value b, but we still need to find the value of a, so we'll plug it back in. A is equal to 2 over 4. So a is equal to 1/2. Which means y is equal to what? Times to the x. And we'll stop here for today. But are there any other questions on anything we've done so far today? We're good with these here? Awesome.